I just wanted to do a quick walkthrough of my on-off lamp module, some people call them smart plugs, that I built with the MySensors Arduino project. I've also interfaced the MySensors project with my Vera home automation controller, and now I can turn the module on or off in a number of different ways. Here I'm using the Automation app, which is an awesome app by the way, to simply turn my lamp on or off. I have another module like this that I built about half a year ago that I've used to do more things than just simply turning it on and off with my phone. I turn on a lamp when motion's detected in a room. I also plugged in a box fan, turned that on when it got too hot in my room, or off when it got cool enough. So once you've got it connected into a home automation controller, there are many other possibilities, especially when using the program logic event generator, or PLEG, plugin with the Vera. I made this module for around $8 because I was able to reuse some parts that I had laying around the house, like my outlet and the gang box. But I'm guessing it would cost about $10 if all new parts were used. I know it's not the most attractive case, this gray plastic here, but it's going to be kept hidden behind my couch, so looks don't really matter to me. It's also good to note that this module can be used with any other hub compatible with MySensors, so you don't have to have a Vera if you don't want. The list is growing pretty fast, so check out the mysensors.org website for more info on those controllers. Also, in the video info, there's a link to a post on the MySensors site that will give more details on this project, including a wiring diagram, a parts list, and the Arduino code. Lastly, I have to give out a quick disclaimer here. This project works with high voltage, so don't attempt any of this stuff unless you're comfortable working with high voltage. Electricity can kill you if you don't take proper precautions, so definitely proceed at your own risk. Okay, enough with the intro. Let's get started.
Okay, so first thing you're going to do is find a cord. I'm using an old computer power cord. I've got plenty of these laying around, so I'm going to use it. If you can see the writing there, it says it supports up to 10 amps, which is what the relay will support, so that should be fine. You could also, if you wanted to use an extension cord, that would work fine as well. You're going to want to make sure it has the 3-prong end on it, though. So I'm just going to take it, snip it off. I'm using an extended gang box to make sure everything fits. I'm going to pry open the ends a little bit here to make it easier to feed the wire through. Break the tabs. And I can feed my wire up through. Okay, next I'm going to strip the wire. So what you want to do is strip down so the ground wire is a little bit longer, because that's going to connect directly into your electrical outlet. And then the white and black wires will be cut lower because you'll connect those into your 5-volt power supply. One of the things I forgot to mention when I was stripping out my wire is you want to leave a little bit extra so you can use it later on in the project to connect into your outlet. Okay, so my power supply, I'm just using an old cell phone charger here. Wouldn't fit in the gang box here with a USB connected into it. So I just broke it apart, just put it in a vise and snapped the casing here. And then I'm going to solder some wires directly onto the DC output here. So the 5-volt and the ground. So I'll just solder those wires so I can save the length from that connector. Okay, so I went in the garage and filed down so the wires would fit through. Not pretty, but it works. Hopefully no one will be seeing this anyway, so it doesn't need to be pretty. The other thing I did was I removed the pins that normally plug into the outlet and drilled out so I can put wires through there and solder them right to there to save a little space as well. Okay, so now that we have our cell phone charger prepped and ready, we can start soldering our wires into it. So I'm going to need the wires going into the charger, so I'll solder them in here and here. It doesn't matter whether it's the white or black, since it's not a polarity specific charger. Then I'm going to need 2 additional wires, white and black, coming out of that that'll eventually connect into my outlet. but first the black one will run through the relay. So I'm just going to strip these and then solder them into here. Okay, so after the soldering's done, slide it on in. I'm just going to tape it off with a piece of electrical tape. Check the connections one more time. Everything looks good. It's always a good idea to test as you go along in different stages of your project, just to make sure that everything's working as you think it will, so you don't have to go back later and try and debug when it's all finished and something isn't working. So now that I'm finished soldering, I'm just going to test to make sure both my AC and DC is working. Now keep in mind, your AC could potentially shock you, so just to make sure you're careful as you're going and doing the testing. So first I'm going to test my DC, so I'm going to set my multimeter to DC here, and then I'll just connect in to my positive and negative, and I would expect right around 5 volts here, which is what we're getting, about 5.5. Now I'm going to turn it to AC, and this is the part you want to be careful with because this is a high current here. So my negative, or common, is the white. I'm just going to try and stick it in there, and then my black wire is the hot. Okay, so there we go, 123 volts. So that's working right. So far so good. So now I'm going to unplug it, make sure I don't get shocked as I continue working. So next I'm going to start assembling the logic part of the project. So here I have just kind of a mock layout of what I want it to look like. So here's my relay over here. I'm going to leave some space over here in case in the future I want to add a current detector module, which will basically tell me how much energy this device is using. I'm not going to do that right now, maybe a future project. This is my Arduino, my Pro Mini here. And then I'm going to have my radio, which will communicate back to the gateway so I can remotely turn this on and off. So this is my universal printed circuit board, so I can just solder into here. Then I also have this breadboard header connector strip here. Got these on eBay that I'm going to use to plug in my Arduino and the radio. So I've already cut them down to size here, and then I'm just going to solder them in. So that way if my Arduino ever breaks, or the radio or something, I can just unplug it. So this is all optional. I could just connect it in with wires if I wanted. I just don't like loose wires in there when I'm working with high current electricity, just in case it would short anything out. That's why I'm soldering it all in. Before I get started with the soldering, I tested to see if this would fit in my gang box, my outlet box, and it's a little bit long, so what I'm going to do is just go grind out this area here so it can slide in there. Now I'm going to start soldering in my header connector strips here. So I've just placed them where I wanted my radio to plug in. I'm just going to turn it over and start soldering them in. Just making sure it's pressed down tight against the board here. I can solder the rest of the pins in. Okay, so I just realized I did not account for the additional width on the radio here. So even though I notched this out on my prototyping board, my breadboard on my radio is going to stick out further. So that's not a good plan. So shouldn't have notched that out. Instead, I'm going to have to make the adjustments over here. So this is what the current detection module looks like. And I want to leave a row of pins on either side of my Arduino so I can always extend out with wires on this side if I want to add additional modules like this one. So I think what I'm going to try to do now is move over the relay 2 pins to see if it'll fit down in my gang box. Okay, so here's what it ended up looking like. Just had to take a small little notch out of that with the file. Being careful I didn't hit any of the circuitry. And then I just sawed off, pretty sloppy job here. Basically these pins are these solder points on the board. So just shorten it up a little bit so it fits up right next to my sensor module if and when I install it. But it fits in there perfectly right in my gang box now. I also added 2 screws. These are just from an old computer hard drive, I believe. But any screws will work just to hold this down onto this board, so holds pretty solid. Okay, so now I'm ready to start wiring. So what I'm going to first do is get some copper lines here, just stripped out some network cable, stripped off the shield. So I just got the copper here. I'm going to wire it right along the back side of this board here for my power and my ground. So because I'm using a 5-volt Arduino and the radio is a 3.3 volt, I need to put a regulator on. So right over here is my regulator. I'm going to mount it underneath the board because it's so small. But I'm also going to put some capacitors in between the regulator here to smooth out the current. A lot of people will post on the forums issues with communication, and most of the time it's solved by putting a capacitor between the radio and the power source to smooth out that power because it's pretty sensitive. So first I'm just going to wire in this, or solder in this regulator, and then I'm going to go and solder in the capacitors. Okay, so what I want to do is I want to have a capacitor going between the input and the ground, the input of the regulator. So I'm going to use a 0.1 UF capacitor between VN on the regulator and ground. And then I'm going to use a 10 UF capacitor between the output and ground. So I'm going to mount those on the other side of my board into the regulator. So now what I'm going to do is connect my 10 UF capacitor between my out and my ground. So my V out and my ground. So with these capacitors, it's important to check for polarity. So this little 0 stripe here means that that's going to go to ground, and then this one will go to your V out on your regulator. Okay, now I'm going to solder my 0.1 UF capacitor to the input, between input and ground on my voltage regulator. This type of capacitor doesn't require any polarity, so you can put it in either way you want. Now I just need to make sure it's connected to ground and to the input of the voltage regulator. Then I'll snip off the wires. So now what I need to do is connect the VN on my regulator to my 5-volt line. So I've just taken a little piece of Cat 6 cable here, left the shielding on except for the ends, and then I'm just going to solder that in. So now that my 3.3 volt regulator is attached, I'm going to solder in my cell phone charger to test it. I found that for me this is one of the most difficult parts, soldering in that surface mount connector correctly. So I just want to test it before I go any further. Okay, so just to test to make sure we're still getting 5 volts from our cell phone charger. There we go. So I'm going to just attach this into ground. It's kind of hard to make the connection with this tight space, but 3.3 volts. So we're good to proceed. Next I'm going to wire up my radio. So first I'm just going to disconnect my power. So I can flip this over easily because I'm going to have to refer to my Arduino and the radio here to make sure I get my connections right. So the pin diagram is on the My Sensors site, so you can refer to that. But what you're going to want to do is know that this is pin 1 on the radio with the little white box around it. That's pin 1, and then it goes 1, 2, 3, 4, 5, 6, 7, 8. And then the pins on the Arduino are obviously labeled. So pin 1 is ground, so that's the first one I'm going to do. So once again, I'm just using some old Cat5 cable to make the connections. So here's my ground, which I'll wire onto my ground rail. Next I'm going to connect in my 3.3 volts. Then I'm going to complete the rest of the radio wiring as indicated on the My Sensors website into the Pro Mini. So I'm going to connect pin 3, 4, 5, 6, 7, 8 into the appropriate pins on the Pro Mini. Okay, so here it is wired up. Got the radio connections here, going to the Arduino pins here, ground and 5 volts. Next, we need to wire up the Pro Mini for power. Okay, so I just trimmed out 2 more pieces of Cat5 cable for the raw and the ground pin on the Arduino. I'll connect them into raw will go into my 5 volt, ground will go into my ground. So right now I'd normally test if I was building more components into this board, but because I'm only putting on this relay, I'm just going to solder in these last 3 wires to my power end to the pin 3 of my Arduino, and then test from there, since that's all we need to do for this program. Then we can upload and test it. So I've cut my DuPont cables here that are just going to go in here and then solder them into the ground, power, and then pin 3 on the Arduino. I'm using DuPont cables instead of soldering them right onto the board because I want to keep this relay removable. If something were ever to happen to it, I'd be able to easily unscrew and then just plug in a new one. Okay, so I'm done soldering all the connections and I'm ready to test. So because I'm using a Pro Mini, it doesn't have an onboard USB. So I need to use this FTDI adapter right here. So that connects into these pins on the Arduino. So I just keep my DuPont cables here connected to my adapter at all times, and then I just know that these color-coded ones here line up with the pins on the Arduino. So what I just look for is my green and yellow, which are my TX and RX, transceive and receive, pins over here on the Arduino, right here. So I just connect it in like that, and then I'll plug in my USB cable into my computer, and I'm ready to upload my sketch.
So now I'm ready to upload my code. I modified my code just a little bit to include some additional things that I like when working with my sensors. So the first thing I did is I just put in a little revision history. As I modify this code, I like to see what I've done, because I don't have the greatest memory in the world. I also included the sketch name and sketch version defined here at the top, and then I'll put them in my sensors message and then send them to my Vera. And I also like to define my node ID. I just specified as 19 for testing here. The reason I like to do this is when I do any upgrades, I'll always have the node ID in here, so I don't need to add it later. Okay, so scrolling on down here, this gateway begin, this is where you'd specify the node ID. If you didn't care about your node ID, you could just set this to auto here, like it is in the code. And this is also setting this as a relaying node, so it will pass messages on to other nodes if they're out of range of the gateway. My house is pretty small, so I don't need that, so I've set that to, well, I just deleted it, so I haven't set it to true. And then this is where you define the sketch info. Like I said, I just have mine at the top, just so I can see to define it when I first modify the code, or you can just place it in here in text. So I just have this sketch name, sketch version. A couple other changes I made is I am just setting my outlet to be off every time I pull the power. So I don't want it to remember the state. So in the setup here, I'm just saying off right away. I don't want it to remember the state from when it was last powered on. I just want it to always come on. Whenever I plug it into to an electrical power, I want it to say off. Okay, and that I also took out this code here to keep that. Basically, it was saving the state to the EEPROM memory, but I don't need that because every time I lose power, I want it to come up as off. Okay, so that's just a walk through the differences of my code and the default. But like I said, I could have just always left the default code here. Okay, so now I'm going to upload it. So what I want to do is I want to check my board is the Arduino Pro Mini 5 volt, which is what I have here. I could always change that if I had a different one. And then I also want to choose my serial port, which is COM13. So now that I've selected those things, I can click on the upload button.
Okay, my sketch has been uploaded, so now I'm ready to test. So I'm just going to solder on my power again. Okay, so I have everything wired up to do my test. The relay, these two connections over here, this is basically off when it's first powered, or in this state. When it's powered off even, it's set to off, as you can see from here. When it's a connection all the way through, you'll see 4 zeros. So that's what I want it to be, is off right now. And then when I plug it in, I want it to be off as well when the Arduino is first starting up. Then I can turn it on if I want to. Okay, so now that I've wired in my power, I'm going to start the inclusion process on the Arduino gateway. Then I'm going to plug in my power. That's a good sign. 2 devices are found. That's all I would expect. The node and the actual relay. So now I'm just going to hit stop here. Then if I scroll up, my Vera is actually going to reload now. After this is reloaded, I'm just going to press Ctrl F5 to refresh my browser, to force a refresh on my browser, and then I can test my relay. Okay, so here's my node and my light switch here. The thing I forgot to mention is what I normally do is I power cycle the node one more time. So I'll just unplug it, and then plug it back in. And what that will do is send the sketch name version over here to my node. So here we have it. So here's my version. Remember, I put that in the code, and then my relay outlet, that was my name. So I'm just going to plug it in. My Arduino powers up. Got my power lights. Notice that I'm still seeing 0 over there. Now from the UI, the web interface, I'm going to turn it on. Probably hear that click. That was the relay activating, and now it's turned on. I'm now ready to put this in my gang box here. So I've already pulled in my 5 volt power and part of my Arduino here, and I've also tinned, put solder on the end of my wires just to kind of make them stick together a little better. So I'm going to attach this into my relay. So obviously I made sure I disconnected the power first before I do any of this so I don't electrocute myself. And then I'm going to put my other black wire here in the other end, which will attach into my electrical outlet. So this one will attach into the hot side. So it does indicate the white here. So white will be on that side and then black will be on the other. Okay, so before I push it back in the box, I just want to test. So all I could find close to that hand was this really old alarm clock here. So now I'm just going to turn it on, just to make sure my connections are good, and then back off. Okay, so one modification I had to make, I put it in the room it's going to finally be in, and I wasn't getting the greatest reception. It wasn't turning on and off every single time. So what I ended up doing was soldering on a piece of Cat5 cable on the end of the antenna. I've tried this on a couple of my other sensors and it works really well for me. Some other people on the forum have said it may actually hinder performance, so I would only recommend doing this if yours isn't working for you, where you end up placing it. But if you do it, what I would say is use the piece of wire length needs to be very accurate, so it can pick up the wavelength of the antenna. I guess there's a lot of science that goes into antennas. I didn't really know that much about it, except for I calculated out the 2.4 gigahertz antenna length, and the one that seems to work for me really well is making the additional wire length 3.28 inches or 8.33 centimeters. And I actually did it from where the shielding starts, because this is part of the existing antenna on the radio, so this part didn't count here. So this antenna length is the 3.28 inches or 8.33 centimeters. So here's my finished product. Definitely not the prettiest thing in the world. Mine's going to be hidden behind a couch, so looks don't really matter to me. And now I can control my light from my home automation, from my motion sensor, from my phone, all for, I would guess this cost me about $8 maybe, because I reused some of these parts. So not bad.